In this video, I'll show you how to solve the ALEKS problem called predicting precipitation. So this gives us two solutions we're going to combine together, and we have to predict whether or not they will form a precipitate, and if they do, what the formula will be. So the first thing that you want to do is take the first combination of solution A and solution B, and you want to write the cation and the anion from each one of these solutions. You don't need to necessarily write this as a compound, like it's totally okay. I'm just going to kind of do this in this spot down here. It's totally okay to just write them as separate ions. So the lead 2 nitrate, that contains the lead 2 plus cation, and the nitrate anion, if you're not familiar with your polyatomics, it's going to be important for you to go look them up and see what they are. Nitrate is NO3 minus. So the nitrate NO3 minus, I'm just going to kind of separate them with a comma. Again, it's not going to be important that I write the full molecular formula of lead 2 nitrate, which looks like this. It's not necessary to do that. I just need to come up with a list of the cation and the anion for both of these. Solution B has the potassium ion, which is K+, and then sulfate, which is also a polyatomic ion, that's SO4 2-. So in order for me to predict whether a precipitate forms when these solutions mix, what I need to do is consider the different possibilities of how these ions could combine. Currently, solution A contains a combination of lead 2 with nitrate. I'm looking for a new combination, like what else could I put with lead? I don't want to put it with nitrate because that's how it already is. I'm trying to do something different here. So I can't combine lead with potassium because those are both cations and it doesn't work that way. You need to have opposite charges, positives with negatives. So combining solution A with solution B gives me the possibility of combining the lead ion with the sulfate ion, and then my other possible combination would be potassium with nitrate. So what I'm going to do is like write out what that formula would look like. If I combine the lead with the sulfate, I've got a 2+ ion and a 2- ion. Those are going to come together in a 1-to-1 ratio, PbSO4. If I'm combining these two guys together, this is a -1 ion, a +1 ion, also going to be a 1-to-1 ratio. Remember, our goal here is to make the positive charges equal to the negative charges in terms of magnitude. So 1-to-1 ratio. Remember, we always write the cation first, so it's not NO3K, it's KNO3. So these are the possible compounds that could be formed when we mix solution A with solution B. What we need to do next is consult a table of solubility rules. And you definitely have a solubility rule chart in your textbook, or you can just look them up on the internet. They're all over the place. One of the kind of maybe frustrating things about solubility rules is that they're presented in a lot of different formats. So the way that solubility rules will look, like if you're looking for different charts, they're all going to kind of look different from each other. ALEKS's table of solubility rules, which you can access over here by clicking in this data box. ALEKS's solubility rule table is kind of nice laid out, but then it's a little tricky because some of the solubility rules say like maybe on them, like it doesn't give you a definitive yes or no sort of a thing. So I'm going to go with this table of solubility rules only because it looks like it's pretty straightforward. And what we want to do is find the rule that applies to each one of these compounds. Let's just start with PbSO4. In general, with solubility rules, you always want to start at the table and work your way down, which means we want to look at this rule first, and this rule does not apply to PbSO4. So now we want to look at this rule, doesn't apply. This rule doesn't apply. Oh, here we have the next rule. We have an SO4. And if we read over, the rule says soluble with all of the ions except for blah, blah, blah. Pb2+ is one of them. So that means PbSO4 is not soluble. Not soluble means that it is a solid. That is another word for precipitate. So does a precipitate form? Yes. Does a precipitate form? That's just asking, does a solid form? And the formula of that solid is PbSO4. When it says empirical, that just means it wants you to give the ratio of the ions, or give the ions in the smallest possible ratio. So instead of writing something like Pb2 SO4 2, it wants us to simplify it, PbSO4, which of course you would already do anyways, because you know that's what you're supposed to do. Let's practice this again with the next problem. So looking at this one right here, again, we want to write the formulas of these ions. Sodium ion is Na+. Be careful, that anion is sulfide. That's not a polyatomic ion, that's the S2- ion. Then we have zinc chloride. The zinc ion is zinc 2+. plus, and chloride is Cl minus. We want to combine these ions in new and exciting ways, which means we don't want to put the sodium back with the sulfide. We've already done that. We don't want to put the sodium with the zinc because that's impossible. You can't combine two positive ions with each other. So that means we want to put the sodium ion with the chloride ion. That would give us, because these are both +1, -1, we have a 1-to-1 ratio, NaCl. Our other option is the sulfide with the zinc. That's a +2 and or I circled that different, +2 and a -2, so that's also a 1-to-1 ratio. Remember, you always write the cation first and the anion second. So now that we know these are the compounds that we may have possibly made, we're going to go to the solubility rules and we're going to look for them. We'll start with NaCl. Rule number 1, Na+, it says it's always soluble. So that means always soluble means that this thing is never going to be solid in when it's in water. So now we're going to move on to our next, ZNS. If we look down our solubility rules, remember we have to start at the top and work our way down. Here is where we have S-, and it says S- is soluble with, there's a list, soluble with calcium, strontium, barium, lithium, sodium, potassium, or ammonium, but insoluble with anything else. So that means it's insoluble with zinc. It's a solid with zinc. So this is going to be ZNS. Last but not least, in this last set right here, we have ammonium, that's polyatomic ion NH4. We have nitrate, that is the polyatomic ion NO3-. We have potassium, that's K+, and we have hydroxide, that's OH-. Ammonium, let's not recombine it with nitrate. Let's not put it with potassium. We're going to put the ammonium with the hydroxide ion NH4OH. That's one possible product. And then the other possible product would be the other two ions together. Remember, always write the cation first, KNO3. Once you get these formulas predicted, go to your table of polyatomic ions. We'll start with the NH4OH, and up at the top, first rule says NH4+, always soluble. So that means that this thing is not going to be a solid. That's always soluble. Moving on to the next compound, KNO3. Rule number 1, again, K+, always soluble. So that means that both of these compounds, they are soluble, or neither one of them are going to be solids. So for this question, we're going to say no, a solid does not form when these two are mixed. And because a solid does not form, we don't do anything in this box out here. We would only do that if a solid is formed.